So today was paper 3 of GCSE Maths, and this question was found very difficult on the Edexcel paper. It's mixing some algebra and some probability. So we've got Y number of counters, there are X number of pink counters and 5 blue counters. The rest of the counters are green. We've got a ratio of X to Y which equals 1 to 3. Freya takes out 2 counters and doesn't replace them. Write expressions for probability of her choosing 2 of the same colour in the form shown below. So right now I'm just underlining the key bits of information that we are going to need to solve this problem. When you're in an exam, I advise you do this because it really helps visualize stuff. So, once I finish, we're going to get started. What we're going to be looking at first is the ratio that we are given. We're given the ratio X to Y equals 1 to 3. I'm just going to rewrite that over here. And we know that ratios can be rewritten as fractions, so that's what I'm going to do below the ratio I've just written. So it's going to be 3x equals y, because you need 3 x's to get the value of y, because the ratio of x to y is 1 to 3. We can use this information later on, but first we're going to try and form the probability of the different counters. So if we take a random counter from a bag, for example, what is the chance we're going to get? We're just going to not express the actual one, we're just going to do it in terms of numbers and letters. So first of all, let's look at pink counters. We have X number of pink counters, so I'm going to write the probability of pink counters is X, because we have X pink counters, and our total number of counters equals Y. I'm just going to write probability of pink in front. Now, let's do the probability of blue counters. How many blue counters do we actually have? We've got 5 blue counters, so we can just put 5 on the top, and as we know, we've got a total of Y counters. Now, let's do the probability of the green counters. Now this is interesting because we aren't given the exact number of the green counters in a variable or a number, but we know that the rest are green and the total number of counters is y, so we can take away 5 plus x from y, as we know there are 5 blue counters and x number of pink counters, and our total is y, so the rest must be green. So the probability of green counters equals y minus x plus 5, just using brackets to make it a bit easier, and that's over y. I'm going to clear the board and we'll be right back. So, I've just rewritten our probabilities here, and what we're going to do is I'm going to rewrite what we wrote at the beginning. Y is equal to 3x. What we're going to do, we're going to substitute in 3x instead of y. So probability of pink, instead of x over y, we're going to do x over 3x. It's so much easier working with one variable because it's just all much simpler, and also the final form that we need to give it in does not have any y's, so it's necessary. So as you can see, I'm just rewriting all of these. I'm sure you can do this. It's very simple. Instead of y, all you have to do is write 3x, and we're going to tidy it up afterwards. So here I'm just going to distribute the negative, or not quite yet, sorry. I'm just writing the substituted version. Now we are going to distribute our negative sign. So it becomes 3x minus x minus 5, because you've got to multiply everything. There's the arrows to show you. 3x minus x, that's just 2x. We subtract 5, and sorry, it's cut off on the bottom, but it's just 3x on the bottom. I'm going to clear the board, and we'll be back for the next step of this problem. So, I've rewritten the probabilities in terms of x on the top. Now, we can start writing the expression. So she chooses two of the same color. So what is the probability of her choosing two of the same color? Remember that when we are doing probability, we want the probability of one thing multiplied by the other if we put both of them, one thing and another. Remember those keywords and. So I'm just showing you here, times equals and then you add the probabilities if you want or. So I've done pink times pink because you want two pinks, pink and pink, or, which is the plus, blue and blue, which is the multiply, or, which is the plus, green and green, which is our and multiply. Okay, so we've got that worded just so we can comprehend it a little bit better. Now we're going to start actually substituting our probabilities, but it's not that simple. She doesn't replace them, so we need to subtract 1 when we multiply, when we write the second term, because when you take it out you have to subtract 1 as Freya is not replacing the marble. So x over 3x multiplied by x minus 1 over 3x minus 1. That's our pink. Now let's do our blue. So we're going to plus. Our probability for blue is just 5 over 3x. So we're going to write that really quickly. Multiplied by 5 minus 1, we can just write that as 4, and then 3x minus 1 on the bottom. Now let's do our green. Plus, our probability for green is 2x minus 5 over 3x, so we're just going to write that in the brackets. And now we need to subtract 1 on the top and bottom. So 2x minus 5 minus 1 is just going to be 2x minus 6. And the bottom is going to be the same as both of the other ones, 3x minus 1. I'm just going to quickly wipe the board, and we will do the last step of this problem. Once you really lay out the steps, get the algebra sorted, and get rid of the ratio, turn it into a fraction, it makes so much more sense. And a lot of people got stumped because they just didn't know where to start. Well, luckily I'm here to show you. So, I've just rewritten out the expression, and we're going to start simplifying it. Now, what we're going to do is notice that all of them have the same denominator. So I'm just going to write the top bits with brackets, because just instead of multiply, because you might get confused and it just makes it a bit easier. 5 times 4 is just 20, and then 2x minus 5, 2x minus 6. And that's all over. That's going to be all over the same denominator, as they all have a common denominator, which is 3x minus 1. Now let's start expanding these brackets. So I'm just going to draw the arrows here to show you. Sorry, they're not the best arrows, but if it helps you visualize, then that's great. X times x is x squared. X times minus 1 is minus x. We could just have the plus 20 there. Now, I'm going to write it on the top in some red pen. 2x times 2x, that's 4x squared. 2x times minus 6 is minus 12x. Minus 5 times 2x is plus 10x. And minus 5 times minus 6 is plus 30. And that is just going to equal 4x squared minus 12 minus 10, that's minus 22x plus 30. And that all is going to be over. Let's expand these brackets. 3x times 3x is 9x squared. 3x times minus 1 is minus 3x. Now what we're going to do is look for our like terms. So in my red pen, I'm just going to underline those like terms that we've got above. So you may notice we've got an x squared and we've got a 4x squared. X squared plus 4x squared is just going to be 5x squared. Now we've got some more like terms. We've got minus x and minus 22x. If you put those together, it becomes minus 23x. Our last set of like terms is our plus 20 and plus 30. 20 plus 30 is easily just 50. And that's all over going to be 9x squared minus 3x. And I think we're done. It's in the form that the question wants. We've completed it, and we know that all of it is correct. That is our final answer. I'm just going to box it to make it super clear. Thanks for watching, guys. See you in the next one.